Hi friends, Mrs. McBride here. First, before we start out our exciting electrostatics unit, I want to start with a joke. What do you get when you cross a vampire and a snowman? Frostbite. All right, so what we're going to do here in our electrostatics unit is we're talking about something called stationary electricity. And should we ever get back to school, we're going to use something like this, which is called a Van de Graaff generator. Not sure if you've ever tried this or seen this, but you put your hand on here and it makes your hair stand up, and we'll talk about why. And I hope you're enjoying this also funny cartoon where it's, have you ever sat on your couch, you slid back and you get that static shock? That's what we're talking about, static electricity. Okay, so let's start by going to page 2. So what's the difference between electrostatic and electricity? Well, electrostatics are stationary charge. Okay, stationary charge means that whatever the charge is collected, it's put in one spot. Now, electricity is the opposite of that because that is moving charge. Still same types of charge, but in this case, the electricity is moving. If you plug something in, as soon as you unplug it, it stops working, right? That's because there's no more charge moving through that object. Okay, well, what actually is charge? Well, there was a gentleman by the name of Ben Franklin who said, you know what? There are actually two types of charge. You've probably heard about his famous kite experiment where he had the kite flying in the middle of a thunder and lightning storm, and supposedly the kite got hit by lightning, and Ben Franklin said, aha, there must be charge. Well, it didn't exactly happen like that. Ben Franklin did fly his kite, but what would have happened if he was flying a kite in a thunderstorm? Well, that charge would have gone right down through him and into his body, so it would have been the equivalent of getting struck by lightning. So my guess is that it didn't exactly happen like that. There's a picture that shows the kite tied to a house. Same problem though, is that if the kite got hit by lightning and the lightning was tied to a house, all of that charge would have gone to the house and probably burned down the house. So we're not exactly sure what happened, but we do know that it was Ben Franklin who said there are two types of charge, and those types of charge are positive and negative. Okay? And we actually have something called the elementary charge. Just like you have elementary school, okay, elementary charge is the smallest amount of charge. Elementary school is the smallest amount of school. Okay, we give this a special letter because, we like to. Okay, and we call this E. Okay, so E is what's called the elementary charge. Okay, and to be specific, this is the charge on one proton or one electron. This is the charge of one proton or electron. Okay, there's probably somebody sitting here going, hey, I thought the charge of one proton was +1, and I thought the charge of one electron was -1. Well, you're not wrong. It's just +1 E, +1 elementary charge, or -1 E. Okay, now I can see you here on the edge of your seat saying, geez, I wish I knew what the value of the elementary charge was. And this is 1.6 e to the negative 19 coulombs. Now coulombs are our new unit here of charge. Okay. This would be something that you should stop the video and write on your green sheet. So I would make a new section on your green sheet called electrostatics and put this information in there. Okay, so I just want to write down here that charge, okay, this is going to have a symbol of Q, lowercase q, obviously. And charge has units of coulombs. Okay, so add that to the bottom of your green sheet, you know, where we add things, right? Okay, and again, I said, what particles have a charge equal to the elementary charge? This is the proton and the electron. Okay, so the proton has a charge of plus 1e, and the electron has a charge of minus 1e. Okay, I'm going to skip this conservation of charge for just a second. I will come back to it. Okay, talking about the atom, where is the positive charge of the atom located? Hopefully you are all saying that the positive charge is located in the nucleus. Is it mobile? Can protons move? Protons can't move. Okay. And where is the negative charge of an atom located? Okay, hopefully you said that this is located in the shells. Okay, and it can move. These are our electrons. Okay, so if something is going to get charged, it's really important to know that it gets charged by gaining or losing electrons. It can't really gain or lose protons, right? Like the math works out, but we know that if you gain or lose protons, it becomes a different element, right? So if we're gaining or losing, so if we're becoming charged, we're basically gaining or losing electrons. That's really important. Okay, and I want to talk to you here. So this one says a certain static discharge delivers 0.5 coulombs of electrical energy. Okay, well 0.5 you might say, hey, that's really small. Okay, this question says how many electrons are in this discharge? Okay, so if we start by saying 0.5 coulombs, and we want to convert, and we know that 1 electron is equal to 1.6 e to the negative 19 coulombs, we could figure out how many electrons there are in this 0.5 coulombs. Okay, take a second and do the math here on your calculator. So you're going to do 0.5 divided by 1.6 e to the negative 19. I'm sure you came up with this, 3.125 e to the 18 electrons. 3.125 e to the 18 is a huge number. Remember, a million is e to the 6th. And that would mean a billion is e to the 9, right? So this is a billion electrons, which is a lot of electrons, right? So electrons don't have a ton of charge. So if you have a lot of charge, it's going to take a lot of electrons. Okay. All right. Last thing I want to talk to you about for this video is something called conservation of charge. Okay. We've had a bunch of things that have been conserved so far, right? I'm sure you're saying to yourself, we talked about conservation of energy. K plus U equals K plus U plus Q, right? We talked about conservation of momentum. M1v1 naught plus M2v2 naught equals M1v1f plus M2v2f. Okay, now we're talking about conservation of charge, and I have some sad news for you here that there's no equation that goes along with conservation of charge. Conservation of charge just means that the amount of charge is conserved. Okay, so if you start out with two things, let's say, for example, you have something that has a charge of -1, and you have something that has a charge of -5. Okay? At some point later, you bring these two objects together. Okay? That's just saying not only will the charge be conserved, but it will also be the same. Okay? In the same way that middle school girls like to come together and be the same, that's the same thing how charge works. It wants to be the same. Okay, so what's the total charge when these two are together? -6. Okay, so then when they break apart, what do you think the amount of charge is going to be? You're right, -3 on both. Okay, so the amount of charge you had before is the same, is the same, is the same. Charge is conserved. Okay, let's just do one more example. If we were in class, I would write this on the board. Okay, so one more example would be like, well, what happens if we do this with a positive? Okay, so now let's say you have +2. okay? And this is brought together with +4, okay? When we bring these two together, the total charge would be 6. And then when we break them apart, the total charge is 3 on each, okay? Charge is conserved. Now there's always somebody who asks me, well, what happens if you take something that doesn't add nicely, okay? What happens if you have +2 and +3, right? Well, when they come together, they have 5. Can you break this into 2.5 and 2.5? No, you cannot. Well, why is that? Well, because remember, the elementary charge is the smallest amount of charge. You can't have a half of an elementary charge, right? It's the smallest amount. It would be like, you know how you go to the store and buy a loaf of bread? Okay? One loaf is the smallest amount that you can buy. You can't go to the store and buy half a loaf of bread. You can't go to the store and buy one shoe, right? That just means that shoes come in pairs or groups of 2. The smallest amount they come in is groups of 2. You can't go smaller than that. The same thing is true with charge. You can't go smaller than one whole number. Okay? So in this case, they wouldn't split evenly. Okay? But charge would still be conserved. They just wouldn't split evenly. Again, charge is something called quantized, meaning that the amount of charge that you have always is going to come in multiples of one elementary charge. Okay? All right, friends, have a wonderful day.